a database abstraction layer that behind that has got drivers for each database. So it's the same idea for us. We support different data sources by these providers. And then actually I should have made this false. Create a new QGIS application. I initialize QGIS, and what that does is basically loads all the providers and all the sets all its paths and everything. And over here I'm just showing some settings for QGIS. It will show you what its search paths are for plugins and for providers. In the same year I'm just showing some application state. And then the actual code here is basically just to get the name of the vector file that I had. So I'm working with this file. This is a vector file with these 3 squares on it. And then I create a new vector layer instance, giving it the path to the file, the name for my layer, and the driver to use to load it. And that will basically load that layer for me and give me a layer instance back. And then I can check if the layer is valid. If the layer is valid, then I can start to do things with it. And QGIS provides an API for manipulating layers. So you can do things like, well, in this case I'm doing a very simple thing. I'm just asking it for its feature count. The feature count is the number of elements or spatial features inside the layer. And but you can do anything to that layer that the API supports. You can change the colors of the layer. It doesn't make so much sense in a console application, but you can do some spatial analysis. You can get each point and then find all the points that are near to it within a certain distance, or any kind of geometric operations that you want to do on the data. You can do it in a standalone application. So when I run the application, it shows this. It shows me the application state, which is where it's looking for its plugins and its themes and so on. And these are all the data providers that are listed in my application. And then at the end it says my layer has 3 features. So it's basically, it's gone and looked and counted the number of points in this layer. If you're using QGIS to program, you have to add to the Python path. The QGIS has got its own Python directory, and that the Python modules are wrappers around. It creates a library like a .so file or a DLL file, and then it's got I don't think it uses C types, but it's got hooks from Python into the Python library. But you have to add this into your path for your applications to be able to find the QGIS plugin API. So we've got Qt, which is the base library of QGIS, and then we've got QGIS itself, which provides a platform for doing geospatial analysis. And then with the work that we've been doing here at AFBR with Ismail and Ollie and Kate and some other people in the room, we've been building this project called InnerSafe. And InnerSafe is a tool for doing disaster contingency planning. So basically, if you want to know, you want to prepare your disaster managers for different scenarios. So you want to say, okay, if you have a flood in a certain area, how much food will we need to supply to people? How many toilets will we need to get them? How much fresh water do they need? Having a tool like InnerSafe allows those people to create these scenarios and understand what the needs of the people would be, and then get their logistics and operations in place so that they can actually provide people with help after a disaster. So I should point out we're not a real-time disaster tool, so we're not like a strategy game where you're looking down at the little people running around and then saying, okay, let's go there. It's more like a planning tool. And the work is supported by AusAid, which is the Australian aid agency, and BNPB, and I won't try to say that out in full, but it's the disaster agency here, and also by the World Bank. And everything that we've done in InnerSafe is completely open source. It's on GitHub. You can download all the source code. I think, I didn't count how many lines of code we had, but it's many thousands of lines, I think, of code. So anybody can go and download it and play with it and improve it or take something out of it that they find useful. InnoSafe is a library and it's a plugin for QGIS. So we have what we call the Safe library, which is basically just a Python package, and that's got all the computational logic in it. And then we've got the plugin, which has got all the graphical user interface, and there's also some computational work in there. And so you could take just the library and use it on a non-graphical user interface environment, or somebody's also made a web application using the library and not using the QGIS parts. And the library contains all the what we call impact functions, which are the tools that actually provide the do the analysis for different types of disasters, flood or volcano or earthquake and so on. InnoSafe is completely written in Python. Trevor said almost completely, but I think it is completely. I can't think of any non-Python code in InnoSafe. And it relies heavily on NumPy and on PyQt4, and of course on the QGIS Python bindings. The website for InnoSafe is at
it also relies on the GDAL, this geospatial, open source geospatial sort of computation packages. GDAL is called GDAL.
GDAL is a library for letting you read geospatial data sets. QGIS also using GDAL underneath. And there's Python bindings for GDAL. So GDAL lets us read in a satellite image, or lets us read in a roads layer and so on.
What is
GDAL. Yeah, they pronounce it Goodle, but I don't know why.
I know, I'll tell you over lunch.
So as Trevor mentioned earlier, the project of InnoSafe as a QGIS plugin is a year and a half now. I think we started something like December 2011 started. And we in the last year we were very privileged to get this award for being one of the best up-and-coming new open source software projects. This award is from the people that make OLO. I don't know if you know the website OLO, which is an open source and analysis site. They read all different open source projects and they get the metrics, how many codes, lines of code, what's the monetary value and all that. And they have something like 600,000 projects like that they collect metrics for, and then they use some data mining and so on to actually select out the most active projects and so on. They use that, and then there's a human vetting process as well before they make the award. And the project is written by people from all around the world. It's an Indonesian project, but with participants from all around the world. So I think we've got Indonesia, South Africa, Switzerland, Indonesia, Norway / Australia in the picture. And there's another guy in Colombia who's working on it for World Bank, and people in Washington also working on it. So InnoSafe, as a plugin for QGIS, it adds this panel to QGIS. And I can do a quick demonstration for you. So the basic idea is that we start with a question always, which is in the event of something, which would be some kind of disaster or flood or earthquake, something like that, how many, and then the thing that will be impacted. It could be infrastructure or people, and then will be affected by, or what will the effect on them be. So in this case, we take from metadata for each of the layers we loaded. We can see over here we've got some flood data and some population data, and there's metadata associated with these layers that tells it whether it's basically a hazard or something that's exposed to the hazard. And based on what hazard and exposure are available, a question is formulated basically by saying what kind of impacts can we calculate on those. So if we know we've got population and flood, we could work out evacuation numbers, or we could work out how many people, yeah, we can work out some flood analysis based on the level of the water and how many people might be affected on that, based on that. And then we can also say we want to aggregate the results, which basically means we can split the results up by a different area, like Kachumartin or Kapubarton or administrative districts. And then if you sort of zoom in a bit, and then you click on Run. What InnoSafe will do is we'll go through and it will run some Python code in the background. Basically, it's clipping these layers to the size that you can see on the screen, and then it's loading them into NumPy and doing some computation on them, and then converting the result back into a new layer and loading it into QGIS, and also producing a report.
Is this the data is online, or you should download it first?
It's on my hard disk. Yeah, everything is running off my hard disk. So you download it first.
Oh, download it first, and you run it.
Yes, so it's all running local. And I think that was like a conscious design decision made as well, that you don't need to have any infrastructure in place to be able to use it. You can just have it, take your laptop somewhere and just use it. If the internet is not working, it doesn't matter, and so on. We have on our roadmap supporting online data sets as well, so that you could say, I want to pull in data from some online resource and then bring it down and then analyze it as well. And in fact, in the next release, we support fetching buildings from OpenStreetMap project, which Kate is involved with, which will dynamically go and download them and load them into QGIS, and then you can do the analysis on that. The report that gets generated shows the statistics based on the area that was analyzed, and it will tell us how many people are exposed to the floods. So this is 138,000 people are in 1 meter of water. And then we calculate the needs of those people. So how much rice do we need? Like if we're providing support for those people, if they've gone to evacuation center or something, how much rice do we need to give them? How much water? How many toilets? And so on. And this is really useful for people who do contingency planning. They want to know how to help the people on the ground. How many resources do they need to provide them?
What about the algorithm to count those requirements? Yeah.
To calculate these?
Yeah.
This is based on national law. It's PAPCA 7. Yeah. So.
Peraturan itu kalau minimal kebutuhan minimanya per minggu.
Oh.
Statik ya. Statik jadi.
Statik tapi ada bisa dimasukin parameter misalkan kalau saya itu.
Next version.
Oh yeah.
In the next version we have. There's some parameters you can set here. In the next version you can also set how much rice does a person need per day.
Can I just answer your question? In addition to what has been said now about this particular calculation, how you can modify it, you can write your own computations entirely.
Yes.
We call them impact functions, and they're like a plug-in into the plug-in.
Yeah.
So, and they will do different things depending on the data types, and they'll detect what kind of data is coming in. And you can say if it is, for example, the hazard is a raster data set, like a grid, and say the data we care about is buildings, for example, it will call a particular function, and you can write that yourself. So in that sense, it's as flexible as you would like it to be.
Ollie's written a nice tutorial on that, which I'll show you just now. So yes, so you can configure them at runtime. The next version, we have more configuration options, or you can write your own complete impact function, or you can just take the default ones that's provided. As part of InnoSafe, we've also written this InnoSafe Real-Time, which is a server-side application. As I mentioned to you before, with QGIS, you don't have to write just things that live inside of the QGIS application. You can write some console application or something. So this is an example of that, where it uses InnoSafe's impact functions together with QGIS API, and all it produces is a PDF. It checks placed on a hard drive for a new data set every minute, which is basically a new earthquake event, which gets the earthquake event gets put onto the hard drive by FTP, SCP, secure copy from BMKV every time an event occurs. And then our software listens for new events arriving there, and it runs some things with the QGIS API and the InnerSafe API, and it produces this one-page PDF showing it's a bit hard to read here, but the number of people affected and where the event was, and it gets pushed onto the BMPB website. And it's all written without, no user has to sit, it's all automatically happening on a server. There's no user interface for it.
So there is similar with the what is USGS?
Pager.
Yeah,
Shake map.
yeah, like a shake map. On
Yeah,
USGS.
it's modeled on that. It's just rewritten and done for Indonesia.
Okay.
Yeah.
But it's certainly inspired by Pager. Very much.
Yes.
This is just better.
So somebody was asking about the impact functions, and Ollie was explaining that all the analysis happens via these impact functions. So Ollie's written a very nice tutorial here. I'm going to find my... So there's this website as part of the InnerSafe website on how to write impact functions, and it basically explains the process that you need to follow to write an impact function. An impact function is just Python code with a standard interface. So you have to implement certain methods on your impact function and return a certain data structure, and then you could put any logic that you like in there. You could use patterns that you find in existing impact functions, or you could use SQL alchemy and Elasticsearch and all these other things and do some crazy things and make a new impact function using those. As long as you have the run method and the metadata and return the right kind of data structure, you can put whatever logic you like inside of it. So, so this is very nicely laid out and explains exactly how you go about making a new impact function. And maybe I can just show the actual logic. So here, scroll down. Really, Ollie should explain this because he understands it better than me. But basically, he's brought the impact, the exposure, the people, and the hazard, the flood, into two NumPy arrays, and then he's using a threshold analysis to find which cells are coinciding with the 1 meter flood level, and then he's putting the results into a new array, and then he's doing some sums of those arrays to find out how many people were in those arrays, and then he does a calculation for the rise things based on these Parker numbers over here. So it's not difficult to write a new impact function. You just need to have some logical basis on which you're writing it. So the last part of my talk is maybe just more kind of I stole the idea of 10 mantras from Ollie because he also gave a talk about 10 mantras. These are my own 10 mantras, maybe stealing some of yours and maybe some new ones. But just some nice things that we learned while we were working on InnerSafe and on using the QGIS API and so on about how to make our lives easier and write nicer code. One thing I would say about working on InnerSafe and working with Ollie and Ismail is that the project is not only focused on getting things out of the door as quickly as possible, but also writing the best quality software that we can write. So it's been a really nice experience working on the software because we can take the time to make the code right and to do things in using best practices and things, rather than just trying to rush something out the door. Because for us it's very important that the code is robust and tested and produces accurate results and so on. So the first mantra is adhere to the principle of least surprise. So I made a contrived example of this where I've got two functions, a get minimum and a get maximum. And this one returns an int and this one returns whatever you pass in. So a user using this API will be very confused because sometimes they'll get an int back and then sometimes you'll get a float back if you pass float numbers and you won't really understand why. You should try to make your APIs so that the person can guess what's going to happen without having to read the documentation. People are lazy, they usually don't go and read that's passed to an int. Actually, my documentation is also wrong, so I've broken the surprise again there. So try to make it guessable, like if you use get minimum in one place in the API, in another place use the same method name and just make it very easy for a person to guess what's going on in the code. We follow test-driven development in InnoSafe, and I actually found that I work better if I follow documentation, test, and then code process. So to do that, I would, for example, if I'm going to write my new get minimum class, I would put a stub in, which you normally would do for test-driven development, and then I would write the documentation for that. And the reason I think that's a really good practice is because it actually clears your mind about what it is that this function should be doing and how the API should work. And so it gives you a chance to sort of think through how this method should work. And then I write my unit test with its checks and calling the new API. And I've already thought about what I should be passing it and everything because I've documented it. And then I write the implementation afterwards. So I would come back and I would replace this pass with some actual logic. And using unit tests and documenting our API well, it's been really valuable for helping us to know that our software is working like it should do all the time and have some confidence in it. This is my new one. I haven't shown this one to Ollie before, but if a function is too long to fit on a page, you should consider splitting it up into smaller functions. Because as your function, the amount of logic grows in that function, it becomes harder and harder to trace through and to test it and to know that your test is covering every part of it. So I made a contrived example again. This one, this guy doesn't have a POSIX machine, so he's running Windows, and I made a long paragraph just to make it long. And I made some funny jokes about Windows 3.1 as well. So imagine you have this long function and you're trying to understand everything it does. Wouldn't it be much nicer if we split it up like this, where we had actually three functions, one that gives the Windows message, one that gives the Unix message, and one that's got the actual application logic over here. And the nice thing that you get as a bonus is that when you want to test the Windows part of the logic, you can actually test it in your unit test even if you're on Linux, because you can just have a test that calls the Windows message directly, where before you have these logic parts that your tests don't always go into because they're platform specific or what have you. So you get a lot of benefits in improving the way that you test, and the code is atomic. You can go to one thing and actually see what it does easily. And it's also very readable, so it's much easier to see, okay, I'm just going to give a Windows message, it makes sense. You don't have to worry about all the details of the Windows message unless you're actually concerned with that part of the code. My next mantra is refactor continuously, and so that means that basically the code is never static. We're always trying to improve the structure of the code, and the code should be a living piece of work rather than something that you write once and just leave it like it is. So, for example, this might have been my first pass at the implementation, and I came back and I read that a month later, and I would just refactor this into new methods, and just all the time try to clean up the code, make it more logical, remove duplication, and just do that on a continual basis.
And can I just say on that mantra 4, that is possible if you have the testing in place that Tim was talking about. Then it becomes a lot easier to do this refactoring when you have a test suite already.
Yeah. So I don't know if you know what obfuscation is. If you're a geek, maybe you've seen the word before. It's like writing code that's very hard to read, and sometimes intentionally very hard to read because you don't want the next guy to come and see how you did it. So there are some fun contests. If you look online, you can find some contests about like obfuscation contests to make the most difficult to read code which does something useful, or in the shortest amount of lines of code and so on. So this is an example of a Fibonacci series written in Python in a single line. And it's basically, you can't look at that and understand it. We had another Fibonacci series earlier today, I saw on the other slide, so it's competing with that one for it's more hard to read. A more simple example is like in the old days, when we had computers, there was always a memory limit, and people like I started with assembly language, and we had to write like little like 2-letter words for variable names and things. So we'd write something like kernel then equals 100 and you get all this funny like things in your code which don't read like English. And with a modern computer, you've got syntax completion and you've got lots of memory. There's no real excuse to write stuff that is hard to read. It's much better to put something that reads like English so that the next guy coming behind you doesn't have to try to decipher your acronyms and so on. Ollie had the rider that if you're a mathematician, you would always like to use X and Y and whatever. And I'm on board with that. But if you're writing anything more like how can I say, humanistic, then it's good to put nice user-friendly names to your variables. I think one of the first coding standard books I read, and it was my favorite one, it was only this small, and it was like 50 pages, something like that. And it said, it doesn't matter what your coding standard is, just have one. And a lot of people argue about, what's the correct way to write your code. But the point is really just to have something in place that everybody, especially if you're working in a team, everybody can work in the same standard, so that, again, you have this element of least surprise, and you know exactly that Ismail's work is going to look the same as mine. If somebody else comes to read the code, it's easy for them to read because there's not different coding styles. So one of the first things you do if you make a project is you should just write down what your coding standards are. And I treat this as a living document as well. So, I mean, you're always discovering new things, better practices and so on. So your coding standards should be able to be updated to adjust to new things. But you should have some standards in place. So in UNICEF, we for example, use PEP 8, which gives all the spacing rules and how wide your line should be and so on. And then we also use a number of other self-made sort of conventions. And then we use tools to check those things. So we've got unit tests that actually go and check that our code is standards compliant. And actually we found a lot of small subtle bugs that happen just by not coding to a standard. So we use the pylon tool, for example, and you often find things like you've got masked variables, like one variable you've defined somewhere else before and you've masked it in another place, or your exceptions are too broad and you're covering every kind of thing, including things that you didn't mean to cover. So it's really good to get some standards in place and then use these tools. This one is, a lot of people spend a lot of time writing the most optimal code and everything. And in many cases, code doesn't need to be optimized. So I mean, if it runs slowly, but it's in a non-timing critical place in your code, who cares? If it runs slowly and everybody's sitting there drumming their fingers on the table waiting for it to finish, then you go and make it faster. I was also contriving an example to show that, and it was actually quite fun because I made this example with the slow method to add 3 numbers and a fast method. And so my slow method would use the Python style call just to take a list of numbers and get the sum of them. And then my fast method was just to add them up 1, 2, 3 like that. And actually, this is kind of like, looks nice for me. This looks a bit, I don't know, preschool for me, or like a bit childish. But then I wrote a little test here to see which one is actually faster. and I didn't make a screenshot of it. That's terrible. But actually, this one is it takes twice as long to run that way as it does to do that way. But the point is really that who cares? If your code looks nice and it's not in a timing critical place, then make it look nice first, and then if you find that it's slowing everything down for the user or it's causing a problem, then you come and optimize it second. Okay, the next mantra is about testing. And really the idea is that it shouldn't be hard to test. If it's hard to test, then people won't run their tests. So we use something called Jenkins, which used to be called something else before that. And basically every time a commit happens in our source tree, then the tests are run. And we've actually got different Jenkins jobs for different parts, different branches in the code tree. And so you don't have to, I mean, we do test locally as well, but also the tests are happening for you in the background, and it also creates some kind of like social platform for the coding that we can sort of like joke with each other, your test failed or something, and it becomes a bit embarrassing if you committed something that failed, and it creates an incentive to make sure that everything's passing all the time. And so we try to really invest some time to put in the infrastructure to make the testing happen as painlessly as possible, so that you don't need to think about it. You just commit your code, and you know the test will run, and you'll be able to see if the code is still at its quality level or not. I think you said if it's not tested, it doesn't exist. What is your name?
Yeah, I said that too. If it isn't tested, it'll be
yeah. So basically, if you're still making zip files like version 1, version 2,
copy folder,
copy folder, then you must come into the 2013 with the rest of us. You should be putting your code under version control. It's saved our project in our work so many times when we discovered we did something wrong, and it was like last week, and what did I do? And then we go and do a binary like search back through the commits, and we find the specific place where it changed, and we can isolate the exact change. We had one actually, Ismail had one. I had one like this in the week where I put in something to test, and I left it there, thinking it didn't matter, and actually it was crashing something in Windows, and we couldn't understand why is it crashing, and then we just started going back through the commit history, and we found this one place, and we saw this one line of code, and we deleted, and everything was fixed. But you don't get that if you're making zip files and things like that. So use a version control system. And the last one is about just being a good citizen in your coding project. So often you improve the way that you do things, you come up with new ideas, and it's tempting to want to go through your whole code base and like make a big change across everything. But what we do is we rather say, we've got our coding standards. Every time you work in a file, you should leave the file in the state of your coding standards, and you should leave it in a better place, in a better way than you found it. So if you in a file and you find that there's a doc string missing, then you should just quickly add it in while you're working the file. Or if you find that there's it's not PEP8 compliant, or it's not nicely formatted, or there's a spelling mistake, just leave it better than you found it. And that way, by increment, your code is always getting better and better, and you don't have to do big sweeping changes to your code to make it better all the time. Just as you're working, you're improving it. So as I mentioned, we're using a lot of these tools like PEP8 and Pylint and Sphinx for documentation, and there are a lot of tools out there to help you make your code better. So it's not a manual thing. And we use PyCharm, it's the IDE. I don't know if you know this one. I was a Vim user for like, I don't know, 15 years or something like that. And I had like a conversion over to PyCharm because I just discovered it's just so much more efficient to use something that is checking your code for you. It's helping you refactor. It's doing all these following my mantras for me. And it's really worth investing in good tools that are out there to make your coding more productive.
And Sphinx is, PyCharm is free if you can document or prove that it's an open source project you develop. You can get it for free. PyCharm. So the conclusion of my talk is if you're a Python programmer looking to do anything with geospatial, with the geospatial aspect to it, we've got great tools out there for you. They're all open source, they're free to use, and
you can do all the spatial analysis you need to with the tools that we have. So I'd just like to thank the sponsors and supporters of InnoSafe for putting food on my table. They give me employment, and I also have a wonderful time working with the InnoSafe team. It's really stimulating place to work. We're always learning things from each other, and so it's been a really great project to work on. And I invite you all to come and participate in the project, and we're always looking for new contributors and new interested parties. Any questions?
First thing, I personally really appreciate what the QGIS built right now, because since college I was using proprietary software such as ArcGIS or everything else, and then I found QGIS, you have open source for the GIS also. Because the time is not so much, right, about the GIS application that open source, and yeah, I really appreciate about the QGIS project. And I wonder what is the next goal for the QGIS project. I mean, what is the roadmap of the QGIS itself outside InnoSafe and other projects like this? Do you have some roadmap you want to make this application for the future, like I don't know, yeah, if you have it, and if there's any roadmap on it, and what is like. And next, maybe what the integration for the web mapping applications such as OpenLayers or GeoSurfer. You have another Smart Surfer. Is there any development to integrate those web mapping, open source web mapping application also, or is there anything? Yeah,
okay, good. So the first part of the question about the roadmap for QGIS at the moment, we are busy getting version 2.0 ready, and that's a massive leap forward in the functionality of 1.x releases, and has huge number of improved features. It has for corporate people, it has Oracle spatial support, and for we have like new symbolization infrastructure. We have improved Python support. There's just huge number of improvements to the code base. So we're busy getting that ready for release, and then we'll start planning what we want to do for 3. But usually we'll probably just take a break and like think a bit about what we want to do next. We have in QGIS, we have every 6 months we have a Hackfest, like a meeting of the developers, normally somewhere in Europe, and we do some planning and some code, mostly coding, but also some planning there. So we'll start to think about what new things we have. But I can say definitely the main things that will be coming in the future will be better like collaboration and social tools. So for example, at the moment you create your symbols in QGIS and you store them on your hard disk, but we're moving to like a cloud idea where you can like store symbols and publish them to the cloud, and then other people can share symbols. You can search for symbols, and I mean not only like pictographs, but also like the colorings and styles that you make for things. So if you've worked out how to color OpenStreetMap layers very nicely, you can just publish that into the cloud, into like a shared repository, and so we'll definitely be bringing a lot more sort of like social sharing of the work that you do in QGIS to make it easier to find symbols and to find styles and things like that. And then yeah, we also from the second part of the question in terms of the server side things, we already have a QGIS server project. I don't know if you know that it exists. So in that first slide I showed you, where we've got QGIS Core and QGIS GUI libraries, we have this QGIS server, which is basically another application built on top of those 2 libraries. And I may be able to demo it if I can find. maybe offline I'll find it. I need to find the URL. But basically, the QGIS server has two parts. It has a QGIS web client part, which is a web application all ready to use. It gives you something that looks very similar to QGIS with a list of layers and a map window and some toolbars.
So it's like a web.
It's
Web.
it's using open layers.
Okay.
It's a web JavaScript library that you can deploy into a website, and then your users can view your QGIS project using this library. So you basically you open QGIS, the desktop version, you add your layers, you do the styling, then you publish that onto the web server, and then you put this QGIS web client in front of it, and then the user comes in and he sees the same layers that you had on your desktop, but he sees it as a web project.
And the QGIS web client is different things like open layers.
Sorry?
I mean, is it same thing like open layers with QGIS client, or it's a web-based application?
It's a web-based application in JavaScript. It uses open layers for the mapping part. It uses QGIS server to serve the maps into open layers.
Well, I mean is what is the difference with the open layers? Because what I know is open layers is doing something like that also. You get a WMS or VFS or something.
So open layers, you can think of it as a GIS browser for the web, okay? But it doesn't publish the data. So, so you need to connect to a WMS or WFS server to publish it. And it also doesn't give you like the layer management. Like in our client, we have a list of layers, like a legend on the left. You can turn them on and off. And open layers also doesn't understand QGIS projects. So with our implementation, you can publish your project, and then it will automatically add the layers from your project. So it takes a lot of the work. You could use open layers on its own with the QGIS server backend, but the web client does a lot of the work for you. It sort of automatically makes the layers available and so on.
So the QGIS server is more like Geo server or map server, something like that. And
then the web client is basically more like open layers, but with some extra things added to it. So. And there are other actually web clients made for QGIS as well. We've got one official one, and then several other people have developed independently additional ones. So if you like PHP, for example, there's one done with PHP on the server side and with caching and things. But this is a Python meeting, so I will not talk about it. But so we have this infrastructure in place. The one thing, if I would say honestly, is that it's not very fast compared to like map server or geo server. So you normally want to use some kind of tile cache in the front of your layers.
I mean, actually, why not you? The roadmap of development is trying to make a plugin for after you edit it in the QGIS, then you publish it using geo server, or you publish it using map server.
We have already a plugin. It's called QGIS Cloud. And there's a cloud service where you basically, it will take your layers and publish them to a cloud PostGIS instance. And but it's actually using QGIS server in the back end for that as well. But yeah, you could write one that pushes it to geo server or something like that as well. But the thing with the advantage of using QGIS server is that all your styling from your desktop is published. And it's hard to always go to other platforms and get the same styling. And I'm biased, but I think in QGIS we have the best capability for styling, like of all the open source projects. So if you want to make like a rich, nice looking map, you can do it in Napnik and these other low-level tools, but they're really not very user-friendly to do it. And with QGIS you can just point and click and draw a nice thing, make nice colors, and it's very easy to make good-looking maps. It's also easy to make horrible-looking maps. But
my question is INASEC able to tell us how to distribute the logistics?
In terms
the disaster existing.
So just clarify what you mean by distribute.
Well, let's say there's a flood. And we know how much rice and the toilets and the rest of the stuff. And is INASEC
moment, no. Although we have a component called Aggregation, which allows you to break the report down by areas. So you can say for this Kapubarton or Kachimarton, this many people need this much rice. And so, but it won't tell you, drive the truck on this road and put the rice in this building. It doesn't tell you that level of detail. It will at least tell you for that area, how much is needed. And then, the tool would be used alongside with other logistics tools for people to actually work out, the route and which building to put it in and so on. Maybe that's something we would add in the future. Just depends on the way the demand is.
There's a plugin for route analysis for QGIS.
Mm-hmm.
So if you wanted to sort of plan the fastest way to go somewhere and take into account for flooding, you can use it to do that. But it's not within NSA.
What are other disasters besides flood that NSA could support?
At the moment, it's volcano. Tefra's taken out. But, the volcano, earthquake, flood, which is tsunami and terrestrial flood, and what did I leave out? Volcano, earthquake, flood. And but because it's extensible, you could add something new like fire. Maybe it's a good time to have a fire one because of all the fires or something.
If you have a hazard layer, you can copy. If you have a hazard layer, a new one you can quite easily create a plugin for an impact on it.
Gilang
You
is
know how to write Python code.
Gilang idea is about alien attack.
I watch Man of Steel too much. Alien attack.
Alien attack.
Are there established models for modeling? And don't forget zombies as well.
That's a great idea. Zombie attack.
Yes, so the floor is open.
No more question?